this will be the way I will explain calculation for bill of quantity. One side I'm going to use Excel sheet, the other side will be a drawing that I will explain we'll get the detailings from. If you remember, we said that there is a chart or the table that we're going to use it to arrange the materials bill of quantity. The way that we're doing it, we will categorize them according to the works. For example, we have excavation, we may have filling, we have concreting. Concrete will be two-part: reinforced concrete, plain concrete, formwork, plastering, gypsum plastering, cement plastering. So we categorize them according to the work. So the first work we will start will be excavation. Now you can name this one excavation and you can call this one A. Then under excavation, whatever we have for the excavation, we'll write them here. Now excavation will be for what? Before excavation you might have something else. Top stripping. If you remember, we said the first work that the agent will do or the contractor will do, will go to the site and clear the site. We'll take that 15 centimeter out of the land. But in order to do that one, we need what? We need the site plan, not just the area of the building, the site plan, because that top stripping that is gonna strip like 15 centimeter or 10 centimeter, they will take it from the topsoil. That will be the site plan. So if, let's say that if there is a site plan, let me just bring another example that there is a site plan to tell you about that one. Let's say if I have, let's say this one. Now if you have a site plan, you'll be able to calculate the top stripping area, because you will take 50 centimeter soil on all the project area. So there will be a site plan that the whole area of the project, this is the whole area of the project. Yes, the house will be here, another house will be here, but the whole area will be stripped off. So you will calculate this area, and 15 centimeter or 10 centimeter the soil will be taken off. This will be a part of the bill of quantity as well, because it's work, required work. So if you have the site plan, like how much is the project area, you can just simply put the site stripping off. That's also possible. But in the project that I have it here, let's say I'll talk about this one later. For now, I'll focus on the excavation. Now when we say excavation, what we need to go to foundation plan. So the type of the foundation will tell us how we have to do the bill of quantity. How many types of foundation we have? Might have single footing, combined footing, or may have wall footing, or raft foundation. Whatever the type of the footing we have, at first we have to know. Then accordingly we will calculate the excavation. Now something I have to tell you, if you have an excavation, now let's say it doesn't matter whatever the excavation it is. Now when we do whatever the type of the foundation it is, when we do the excavation, we normally excavate more than the foundation. For example, we excavate something like this around the foundation. Why? In order to put the formwork, you have to put formwork, and then you put the concrete inside here. But for the purpose of the theoretical calculation, we only consider the area of the foundation for the excavation. But practically, if you're working with someone, you have to take this one into consideration. Say, okay, if we're going to use formwork for the foundation, then you have to excavate more, at least half meter in each side, to have a space for the formwork. But in the class here, we're not going for these things. We only take care of the area of the foundation. So here we have a raft foundation. I already explained this one. We have a raft foundation. So the area, we have only one excavation area here. We have mat foundation or rat foundation. Mat foundation, I have it here. Now how many of this mat foundation I have in this project? 1. If I had 10 houses, I could just say times 10. Well, maybe it was a combined footing. We'll come back to we'll show you different types that this number, which we will call the repetitive. Do you have any similar mat foundation of this one? I only have one here, so 1. The length of it, I will take it from here. On the plan, for example, here it's written 1630 centimeter, but this is to where, be careful, it will be 16.3 meter. But if I go to the top, I will see that this is up to here. Now this architecture uses this one instead of arrow, uses this one. So this is up to here. Then we have an extra 60 centimeter here, and if I go to the other edge as well, I will see the same thing. If I go to this edge, I will see another 60 extra centimeter here. So the total length, I can calculate it. That will be 16.3 from here, 0.6 that side, 0.6 the other side. So total, we write it here as the length will be 17 point, this is 60.3, 1.2 will be 17.5 meter. Now the width of it, the same way I can get it from this. Remember, you have to know this is the foundation, you have it, then I can get the same way, 840, 60 there and 60 on the other side, so 1.2 with 8.4 will be 9.6. This is 9.6. This is how you collect the length and the width. Now when it comes to height of excavation, like remember, this is excavation, yes, not the footing, this is excavation. So we want to calculate the depth of excavation here. How much we have to excavate? We need to know the ground level and the level that the excavation will be. Now we said on the excavation something will be given like this, 0, 0. So this is the top of the excavation. When we know that 0, 0 is what? The ground level. So it means that for this project, ground level is somewhere right here. This is the ground level. So we know that we have to excavate 40 centimeter for the raft foundation and 10 centimeter, which is concrete under it. A concrete under it. So the total depth of excavation will be 50 centimeter. I need to be careful. Not always will be this 50 centimeter. Why? Because it was given to us here is 0, 0. That's why we will choose this one, 0.5, as the depth of the excavation, 0.5. Now let me show you some of the example. I have it here, another example. This example also, it's raft foundation, but look at the top of the excavation is minus 3.3. So minus 3.3, what does it mean? It means that the natural ground level is somewhere here. 0, 0 will be somewhere here. This is very important, and this is always you're going to use it to know the depth of the excavation. So if this is minus 3.3, we know that this is, and plus this will be the depth of the excavation. So here we have 0.8 and plus 3.3, so total depth of the excavation will be 4.1 meter. This will be the depth of excavation. You have to excavate this much, then you will do the things under the footing. Well, you might have different, I don't know, each plans they have different way. For example, this one, let's see if I can, this is not that static, let me just bring down. Now this is not a rough foundation, but it doesn't matter, this one, it's a combined footing, like this is T4, there is another one T7, a combined footing, and BK will be the ground beams. But again, I'm looking for this one. Let's say I'm talking about the height first. Plus 0.5. It means that the natural ground level is somewhere right here. This is 50 centimeter plus we have it, so this is 0, 0. This is 0, 0. So we know that if there is something below here will be the excavation. For example, this is 55, so we have 5 centimeter excavation depth here. Or maybe something under it will be given, whatever it's given here, we will add them as well to be for the depth of the excavation. So when you want to find the depth of excavation, you're going to check the level, the top of the foundation, in order to know where is the ground level. Then below the ground level will be the excavation. I'll come back to these things to explain more about the type of the foundation. But let's say I have this one. Now we're going to calculate, do we have any, for example, empty places here, or hole, or something that to be extra added around the edge? If I had, I could simply add it to the plus and minus. If not, I will calculate. So the way that we're doing it, this is a plus amount, yes, because we're calculating excavation. We can use it in the plus side, equal to the number multiply by this one, multiply by this one, multiply by this one, and hit enter. So you say equal, you multiply this by this, by this, by that, equal, and you get 84. This 84 is what? It's plus because we're excavating. Then the unit we're writing it here will be meter cube. Now here the quantity will be what? Will be equal to this one plus this one. Now someday we'll write minus here. This is still okay. We say this one minus this one. What does that mean? If I have something to take it out of this excavation, I'll put it inside here. I'll prefer to write it plus this one. You will understand it later. I don't have anything to take out of this 84 cubic meter, so that will remain here. Let's say if there was something here on the here, for example, there was something like this. There was 1 meter by 1 meter, an empty space. For example, let's say this part cannot be excavated. It's something imaginary, but let's say that this part cannot be excavated. This part 1 meter by 1 meter. Then this is supposed to be taken out of this area. So 1 times 1 times 0.5. So in order to do, some people, you have to calculate this one. Here's 1 times 1 times 0.5. Then you write it here as minus something, as minus whatever. Then it will be taken out from this value there. You'll see this one in the doors and window. Well, however, I don't like this way doing it. This is some people doing it. I don't like this way doing it. So what I will do, I will just simply remove this one. I'll say I will do the calculation here. This multiply by this, multiply by this, multiply by this, equal to 84. So here I will write plus sign here, as I know that this is a plus, or I can tick something here to know this is plus. This is plus. When I have minus, I will do them here alone, then I'll put a minus here, then this value will be minus. When we do summation, it already will be taken care of. You will understand this one when we come to door and walls, especially when we have a lot of windows inside it. You will see which one will be easier to do. Some people, they will do separate. They will start another section. They will do like this. They will say excavation, then I'll say minus. They'll put it like this, excavation minus. So this will be the things that will be taken out of the excavation. That's also totally possible. So whatever you prefer, it's up to you, but you have to know that if there is something to be taken out of it, you have to do calculation. Now for this project excavation, it's 84 meter cube. We have it here. Well, if I want to do this one here, let's say I have this project. This project has different foundation design. It's a combined footing design. We have it here. So there is multi-combined footing. Now, how do we know it's a combined footing? Like this is foundation plan, and foundation that connecting columns together. Under the columns, those will be the foundation. Those are small. We call them ground beams. Now the idea of ground beams here is what? If you have a single footing or if you have a combined footing, normally you have a ground beams that connects the columns to each other to make it a stable foundation, in order all of them to work together. This is in the foundation design. You will learn this detailing. So if you realized here, everything linked together. So you have the footings. So if I highlight the footings here, this is, let's try to make sure it will be clear. So I will highlight the footings. This is I have a footing here. This footing is kind of a bit, so there is a footing here, there will be a footing here, we have it, there is a footing that combine those three, there is a footing here combine those two, there is another footing coming from there, there is one here. Those are the footings. I'm sure this is the footing as well. It's kind of a bit, yeah. This is also another footing. The other footing we have it there. All of those are combined footing. The between them are the ground beams. Now, the name of ground beam comes from there. The name of ground beams, it basically a beam on the ground, on a natural ground. So this is kind of tricky. It's supposed to be like this. Beam on the natural ground. This is what we call beam on natural ground. So in some of the places, you will see that they will do some miscalculation for this value here. Let me tell you, this value here, the level of the top of the foundation, that the ground beams will not be on the natural ground. So sometimes you have to be careful. Whatever the plan is, you're going to go through it. So, but do not always say that since we have a ground beams, yes, those will sit on the ground. You have to check to see if they haven't made any mistakes in the calculation. Normally, we do it in this way. Ground beam will sit on the ground. So, how do we do this type of footings? Are we not going to be one? They have to be one by one. So, it's starting from T1. What we write here, for example, we write T1. So T1, it's a foundation. How many of T1 you have it? Now when we say how many, like the length, the width, the height, all of them to be similar. If you can find similar of T1 somewhere else, exactly similar, the same length, you can number them here 2, 3, 4. But in this case we have it here. In the case we have it here, I mean they are irregular, we don't have the same as this one. So I'll call this one 1. I'll call this one 1. Now the length of it, again, we'll get it from where? From here. You'll get it from here, the length of this. How much the length of it will be. So you will calculate this length here. For example, 170, 150, 235, 95. This is from where? From center to center. This is from center to center. You add all of these values. Plus you have what? Plus you have 70 here and 70 here. This will be the length. This will be the length. The width of it for the combined fitting will be given like this to us. Will be given like this. So the 70 here is the width. The 55 is the thickness of the foundation. Thickness of the foundation. So I have the width 0.7. I don't know how much will be 170, 150, 235, 90, 270 there. We can, by the way, we can use Excel to help us to find these things. Why? Because Excel can do the calculation for us. I can write it like this. 1.7, I'm converting it into meter, plus 1.5 plus 2.35 plus 0.95 plus I had 270s at the corners, plus 0.7 plus 0.7. Look, I can simply get it 7.9 meter the length of this footing. I just added all of these together. That became, I don't know, I made a mistake, 1.7, 1.5, 1.7, 1.5, 2.35, that's it, 0.95, 0.7, 0.7. Then the width of it is 0.7, as we said that here. This is 70 centimeter. Now, I'm not gonna write 55 here, remember. The height, this is excavation. We need to know what? We need to see, this is plus 50. So plus 50, it means that the natural ground, it's somewhere here, which is 0, 0. Then since the depth of the excavation is 55, so we're gonna go 5 centimeter below the ground level. Now normally there will be something under it, so well, with a plain concrete, something sand, but he is not given, so we'll consider this one to be 5 centimeter. Look, here we know that there is something missing, yes, so we can simply ask the designer, is there something under the footing? Do we have something under the footing? Which most probably we have it, just the plain concrete or something under it. So in that case, we know that now 5 centimeter, here 5 centimeter, but if we had something here, for example 10 centimeter for the plain concrete, we know that this is the natural ground, then if this is 5 and this is 10, for example, then it will be 15 centimeter the depth of excavation. We're gonna write it here, and it will multiply them, we'll get this one. Then you repeat for T2 the same way. So T4, T3, all of them, you have to name them. You have to name them so that later if you feel that there is a mistake, you can come and check them one by one. If you missed anyone, you can see it here. T1, you will write all of them down and you will do their calculation. This is how you do excavation. Now, do I need excavation for the ground beams here? Do I need the excavation for ground beams here? The ground beam basically sit on the ground, yes? So if this is, for example, natural ground is here, then we don't need any excavation for the ground beams here, yes? No need for this, any excavation, because this is a 0, 0, we have it, the 0, 0. So the ground beams will be above the natural ground, so we don't need excavation for the ground beams. This is how we do soil excavation. Now, sometimes you need to check what around the building, not just the building itself. The fence, you may have excavation for the fence, or the foundation for the fence. Sometimes you have other things, that the sidewalks, the pavement within the project. Let's say, for example, I have this project, I will check to see if there is any road here, for example. Is there any sidewalk we have it around this building? If there is any, for example, we need to do excavation. For example, here I have what? I have swimming pool. So if there is a swimming pool, I have to do calculate this one, we write here swimming pool excavation, which we need to know again the same way. You take the area here and you will go to the sections, to see exactly if there is any which is given here for the swimming pool. I'm not sure, it's supposed to be given somewhere for the swimming pool, to know the exact location, which is minus 160 is here, and you have it here. Then you will calculate the total depth of excavation. This for the swimming pool. So the swimming pool. So I'm coming where to get the elevation, minus 160, so 1.6 meter from here, and extra we have it here as well, 45 centimeter, so it'll be 205 centimeter the depth of excavation. In this manner we will find the depth of excavation. The areas will be taken from the plans. That's all about excavation. I'm not going to go into detail of them. In the next video we will explain more for the soil, still working with the soil, maybe compaction, filling, those things. We'll talk about them in the next video. Thanks for watching.